So today in class we started talking about how to add and subtract rational expressions. And it's very similar to what we have to do when we're just dealing with numerical fractions. If they have the same denominator, we can just combine the numerators and write it over the common denominator. If we have unlike denominators, we need to find that least common denominator first. So first we looked at adding or subtracting rational expressions with like denominators. And just like with numerical fractions, all you're really doing is performing the operation with the numerators and putting it over the common denominator. For example, example 1, I have 7 over 12x minus 5 over 12x. And so the answer would really just be 2 over 12x. Always check to see if your final answer can be reduced, and this one can. We can reduce this down to 1 over 6x. Okay? Example number 2 is very similar, so we're going to go ahead and skip that. Let's go on to example number 3. You have 4x over x minus 2 minus x over x minus 2. You might want to think about this as 1x. 4x minus 1x is going to give you 3x over the common denominator, x minus 2. There is nothing we can simplify here because this x is a factor since it's 3 times x. This x is a term since it's x minus 2. So those cannot be reduced out. So that is your final answer. If we come over here to example number 4, we have 2x squared over x squared plus 1 plus 2 over x squared plus 1. Now, even though the terms in the numerators are not like terms, we can still write this as one fraction as 2x squared plus 2 all over the common denominator x squared plus 1. Now, if you look at that numerator, there is a GCF that we can divide out, and that is 2. And when I do that, I end up with x squared plus 1. Well, if you look at the problem now, similar to what we've been doing the last few days, we now have a common factor, or a common factor in both the numerator and denominator that can cross out, and so the answer is just going to be 2. Now the problem comes in is when those denominators are not the same. Just like with numerical fractions, we have to find a common denominator. And so what we did today is we didn't actually do any addition or subtraction. We just looked at how can we find what is called the least common multiple, because the least common multiple is going to be what we use as our least common denominator. Okay? If we look at this problem, it says find the least common multiple of 5x squared minus 45 and 4x squared plus 24x plus 36. I approach these problems kind of like a buffet line. I can either relate stuff to money or to food. What I do is I look at these two expressions separately. And I am just going to go ahead and factor each one separately, similar to what we've been doing the last few days. For this one, I notice that both of them have a GCF of 5, so I'm going to divide that out first. And then I notice that what's left is the difference of two perfect squares, which I can then factor down into x plus 3 and x minus 3. I'm going to do the same thing with the problem over here. I first notice that they have a GCF of 4, so I'm going to divide everything by 4. And then when I factor what is left, that will factor down to x plus 3 and x plus 3. Now we talked about in chapter 5 that the best way to write that is x plus 3 squared. And for these problems, it is important that if you have two parentheses that are the same, you do need to write it as one binomial squared. Now that I have both sides factored, what I'm going to do is I'm going to look at the individual factors. And what I'm going to do is, just like I'm moving down a buffet line, I'm going to take one of each item. Now, if it comes down to you having two items that are the same, but one is raised to a higher power, you want to take the one that is raised to the higher power. So, for this problem, my least common multiple, I'm going to go through and take one of everything. I'm going to take a 5. Now, I have an x plus 3 or I have an x plus 3 squared. I need to take the one that has the larger power. Okay, moving on. I have an x minus 3. I don't have one with the powers, and I haven't taken one of those yet, so I'm going to take an x minus 3. I have a 4. And I have gone through all of my factors. So what is left is my least common multiple. I am going to go ahead and do the 5 times 4 and get 20. And so my least common multiple for this problem, oops, excuse me, that should be minus, is this.